Good. So, thank you for coming here. And I will, so this presentation is really a mixture between Eric's presentation and Robert's. And I will explain how to simulate unprecedented events in a rather economical way. So let's start from an event that many of us have still in memory. So let's say the European heat wave in 2003, which had devastating impacts on society, ecosystems, especially if we look at the 15 hottest days in July, August, so which I will call TG15D. Okay, so there were quite a lot of papers after that heat wave, especially in 2004 and 2005, and people estimated the probability of such an event, which was certainly lower than 10 to the minus 4, so with a return period larger than 10 to the 4 years. Some people claim it was 1,000,000 years, but a very large number or very small probability. So, there have been a lot of attribution statements of heat waves lately. And so this happened 20 years ago. And it was estimated that the probability of such an event is multiplied by roughly 10 every 10 years. Okay, so now we can expect that the probability of such an event is around 1/10 or something, a small number, but much larger than what it was in 2003. Okay, and the fourth point I want to make is that if you look at middle of the road SSP scenarios in CMIP6, then such an event is almost sure by the end of the 21st century. Okay, but I won't be there by at the end of the 21st century. Maybe you will, but I won't be there. But it turns out that the question that we are asked is, by the middle of the 21st century, what can we say about this? We know it's almost sure at the end of the 21st century, but now we are at the first quarter of the 21st century. Can we get this? Okay, so let's go back to this. Can we exceed the 2003 TG15-day record in the present day decades? Okay, so that includes the Paris Olympics in this year. And by how much can we exceed such a record? So those are the two starting questions. Now we have a very pragmatic scientific question. We want to exceed such a threshold, but we want to exceed it. But we need to have a lot of samples of such an event just to make statistics and make useful inference on such an event. So the scientific challenge is how to obtain 1,000 samples of events that have a return period larger than 10 to the 3 in present-day conditions, not at the end of the 21st century, but now. So we found out that we need more than 1,000,000 years of climate model simulations, and we don't have those. And we don't have those in CMIP6. We don't have those in general. So what can we do about this? Okay, so Eric presented something that can obtain such types of events. And the third question is, what are the meteorological conditions that prevail during such events so that we can make forecasts, actually meteorological forecasts of such events? Okay, so we have developed strategies in XAIDA. So Eric presented a boosting strategy of climate models. And we have worked on a statistical strategy, which is called stochastic weather generators, which are emulators, climate emulators, which are based on climate models or reanalysis to obtain very intense events. So stochastic weather generators are simple forms of artificial intelligence. They are very flexible and they are low cost, so they can run on a laptop computer. And the challenge there is to make the physical validation of the simulated events. So there are strategies to do this. And how do they work? So that's what I wrote in boldface. So there are random sampling of atmospheric patterns that favor the hottest temperatures. So if we want to simulate hot events. Okay, so let's go to the results. So we were interested in the hottest streak of temperatures for 15 days around the Paris region, so which is there. And we did this based on CMIP6 simulations. So we take CMIP6 simulations and we nudge the data, so resample data from CMIP6 in order to favor the hottest streak of 15 days. What we find, so that's this is summarized here. So the red line here is the 2003 record that was observed around Paris. And we find that while in the 20th century, it's very hard to reach such a record. But now if we take conditions between 2001 and 2050, not only we can reach this record, but we can exceed it by a few degrees, 2 or 3 degrees, which is huge. But it's possible now in 2024. Okay, so let's conclude here. So the 2003 record could be exceeded even by 2 degrees, which is huge in the present decades. That is before 2050. So it's not a forecast, it's just a statement that it's possible now to exceed this record. This is consistent with other modeling approaches like boosting presented by Eric, or extreme value models, which is not independent theory of statistical theory. We have looked at other test cases like the 2021 Northwest Pacific heat wave that was discussed earlier. And we are looking at cold spells, extreme cold winters in France and Germany. And here again, we could validate our approach with what was obtained with ensemble boosting that was done with the team in Zurich. And everything is summarized in one of the deliverables of XAIDA, which is publicly available. Okay, so I'll stop here and take questions. Thank you.